Have you ever studied really hard for a test and felt like you knew everything, only to realize a week later that most of that information was gone? It's a frustratingly common experience. This isn't a personal failure. It's a basic feature of how our brains work, a thing called the forgetting curve. First talked about by Hermann Ebbinghaus in the late 1800s, it shows how our memory goes down pretty fast. In just 1 hour, you can forget more than half of what you just learned. In one day, it could be as much as 70%. It feels like trying to fill a leaky bucket. But what if I told you there's a way to not only plug the leaks, but to completely change the shape of that bucket? What if the very act of forgetting could be used to make memories stronger, last longer, and easier to get to than ever before? The surprising secret isn't just to pour in more information, but to pull it out in smart ways. It's about working with your brain's natural ways, not against them. The ways to do this aren't hard, mysterious, or expensive. They are simple, science-backed habits you can start doing in your life today. To understand how to remember, we first need to understand why we forget. Think of a new memory like a barely visible path in a forest. The first time you walk it, the path is barely there, covered in leaves and branches. If you don't walk it again, nature quickly takes it back, and the path disappears. This is the forgetting curve in action. Our brains are incredibly efficient, and they discard information that doesn't seem relevant or isn't used often. It's a survival mechanism to keep us from being overwhelmed by a lifetime of sensory information. So, how do we tell our brain that a particular piece of information is important enough to keep? The answer is surprisingly simple. We force our brain to retrieve it. This is the principle behind two of the most powerful learning techniques ever studied: spaced repetition and retrieval practice. Spaced repetition is all about timing. Instead of cramming and going over the same information 10 times in one night, you review it at increasing intervals. You might look at it after 1 day, then after 3 days, then after a week, and so on. This strategic spacing interrupts the forgetting curve just as the memory is about to fade, signaling to your brain, hey, this is important, strengthen this connection. Every time you revisit the information at these spaced intervals, you're not just passively rereading it. This is where retrieval practice comes in. You should actively try to recall the information from scratch. This is the testing effect. We often think of the brain and body as separate things. The mind is for thinking, the body is for moving. But this is a very wrong idea. Your brain is a physical organ inside your body, and how well your body is doing really affects how well your brain works. In fact, one of the best ways to make your brain work better has nothing to do with logic games or memory games. It's aerobic exercise. When you do an activity that gets your heart pumping, like walking fast, jogging, or riding a bike, you're not just working your muscles and your heart. You're changing your brain's chemistry and structure for the better. The first thing that happens is that blood flow increases. Your brain uses about 20% of your body's oxygen and calories, even though it only weighs 2%. Exercise is like opening up a highway for these important resources to flood your brain, improving its function almost instantly. But the benefits go way beyond just blood flow. Exercise releases a bunch of powerful chemicals in the brain. Endorphins, dopamine, serotonin, they make you feel better, help you focus more, and boost your motivation. Most importantly for learning and memory, exercise helps produce a protein called brain-derived neurotrophic factor, or BDNF. BDNF? The miracle grow for your brain. It's a key molecule in neuroplasticity, which is your brain's ability to form new connections and pathways. BDNF helps existing neurons survive and encourages new neurons and connections to grow and form. It's especially active in the hippocampus, a very important part of the brain for learning and long-term memory. You can spend all day practicing recall and stimulating your brain with exercise, but if you neglect the third piece of this puzzle, much of that effort will go to waste. That piece is sleep. Sleep isn't shutting down, it's an active neurological process. It is, for all intents and purposes, your brain's nightly save button. During the day, you form fragile memory traces. Memory consolidation largely happens while you sleep. Deep sleep, also known as slow-wave sleep, the filing clerk. The hippocampus replays the day's experiences. It talks to the neocortex, your long-term storage hard drive. This transfers and solidifies factual knowledge and personal experiences. REM sleep, the creative integrator. REM allows for new connections between memories. This is why you might wake up with a solution to a problem you were stuck on. How to optimize. The most important thing is consistency. Go to bed and wake up at roughly the same time every day, even on weekends. Aim for a consistent sleep window of 7 to 9 hours. And during the day, yes, there's a way to get a quick boost: the power nap. A short nap of 10 to 20 minutes can be remarkably effective. It provides alertness and better performance without causing sleep inertia.
Subscribe to our channel for more new ideas and education. Hit the like button on this video and share your thoughts in the comments.
Tip 1. Stop caffeine at least 8 hours before bed. Caffeine can mess with your sleep structure, especially deep sleep. Tip 2. Set an alarm 30 to 60 minutes before bed to wind down. When it goes off, turn off screens. Blue light suppresses melatonin. Before you relax, take 2 minutes to review the most important thing you learned today. Look at your flashcards or notes one last time, tag that information as important. You're giving your brain its marching orders for nightly consolidation. In our super-stimulated world, our attention is constantly under attack. Notifications, emails, social media. The ability to direct your attention where you want it is becoming a superpower. Our ability to learn depends on our ability to focus. If your attention is scattered, your learning will be shallow. How do we train this fundamental brain muscle? The answer: mindfulness meditation. Mindfulness equals paying attention to the present moment on purpose without judgment. It sounds simple, but it changes the brain. Our brains fall into a default mode network, pausa. Then that network calms down and the prefrontal cortex takes over. Think of your attention like a flashlight. For many, the beam is wide, blurry, and flickers. Practice makes it narrow and keeps it steady. This improves working memory. How does it work? By running a simple cycle. You pick a focus, most commonly the feeling of your breath. You put your flashlight there. Inevitably, your mind will wander. A thought, a sound, a feeling. Noticing it is already an act of mindfulness. Gently, without judgment, you return your attention to the breath. Focus, wander, notice, return. Each cycle strengthens your attention circuits. Let's do a quick guided practice. It takes less than a minute. Find a comfortable position. Close your eyes if you want. Bring all your attention to the feeling of your breath. Feel the air coming in and the gentle fall as you breathe out. To make this a routine, start with 5 minutes. Stack the habit. After I brush my teeth in the morning or right after my workout, I'll meditate for 5 minutes. Use apps or just a timer. The goal isn't to stop thoughts, but to practice the cycle. So far, we've talked about how to make memories stick, how to get your brain ready to learn, how to make those memories solid, and how to focus your attention. Now let's talk about the learning process itself. How should we set up our practice sessions to be super efficient and truly understand things? The usual way is called blocking, which means practicing one skill or topic over and over again. For example, only practicing forehands in tennis for an hour, or only studying one chapter of a textbook at a time. Even though blocking can lead to quick improvement in the short term, studies show it's a surprisingly bad plan for remembering things long term and being able to use what you know in different ways. A much stronger way is called interleaving. Interleaving means mixing up your practice. Instead of practicing AAA, then BBB, and then CCC, you practice ABC, CAB, BCA. In our tennis example, this would mean switching between forehands, backhands, and volleys in an order that seems random. Blocking lets you go on autopilot. After a few minutes of practicing the same thing, your brain knows what's coming. Interleaving forces your brain to stay active. Every time you switch tasks, you have to actively tell the difference between the different kinds of problems or skills. You have to load a new program into your working memory. This helpful challenge creates a more flexible and strong understanding. When you interleave, you're not just learning what to do, you're learning when to do it. The math student isn't just learning to solve for x in one type of equation. They're learning to figure out which formula to use from a mix of different problem types. To make interleaving easier to handle, we combine it with another technique, chunking. Chunking is breaking down a complicated skill into small pieces. You learn one chord, then another, then how to switch between them. You build a complex skill from a library of smaller, well-understood parts. We started with the slightly scary truth of the forgetting curve. That idea that our brain is like a bucket with holes, bound to lose the information we work so hard to learn. But, as we've seen, that's not the whole story. The brain isn't something that stays the same. It's a living, moving system that responds to what we ask of it. Spaced repetition aerobic exercise. Good sleep, mindfulness. Interleaving practice. These aren't just tips or tricks. They are basic ways to talk to your brain in the language it understands. Each of these things sends a strong signal. Retrieval practice says, This is important, save it. Exercise says, get the ground ready for new things to grow. Sleep says, connect and link what we've learned. Mindfulness says, focus here now. And interleaving practice says, don't just memorize, understand. By putting these small, steady actions into your daily life, you're not just patching up the holes in the bucket, you're changing the bucket itself. This is the key to neuroplasticity. The most exciting part is that these effects add up. You don't have to do all 5 things perfectly from day one. Start with one. Choose the one that seems easiest or most appealing to you, and do it for just 1 week. Feel the difference it makes. Then add another. It's about small, smart, and consistent investments every day. Your future self will thank you.
Subscribe to our channel for more new ideas and education. Hit the like button on this video and share your thoughts in the comments. Which skill connects most with your teaching? Which one seems hardest to develop? Your ideas and questions help build our learning community and inspire what we'll cover next. Together, we can change education, one teacher, one classroom, one student at a time. The future of learning is in our hands.